Hey everybody, Mark Bates here, and today I want to give you a get started guide to Buffalo. We're going to talk about how to make sure your system is ready to develop Buffalo applications, and then I'm going to walk you through all the different pieces of a Buffalo application, so when you're developing your own, you understand what's kind of happening and you know where to look to find out more information on the subject. So with that said, let's dive right in. Now the first step to installing Buffalo and to writing Buffalo applications is to make sure your Go and Buffalo environments are set up properly. To help you make sure of that, we've created a little tool called Clara, and Clara can be installed either using go-get from source with make install, or you can go to the Clara site at github.com/gobuffalo/Clara and pull down one of the pre-built releases for your operating system. Once you have Clara, you can run it and it's going to give you a system report that tells you how your Go installation is, as well as how your Buffalo system is. When you run Clara, it's going to generate a system report, and it's going to tell you what is right, wrong, and potentially off about your system for both Go development and Buffalo development. So, to demonstrate that, I am inside of a Go Docker container here. I've installed Clara using go-get, and now I'm just going to run Clara and see what the output is. As you can see, I've got a lot of reds here. So let's start at the beginning and take a look at exactly what it is that Clara is going to be checking for us. So the first thing it does is checks to make sure that Go's installed. Now this is a Go Docker container, so Go is there, and it even tells us where exactly our Go binary is located. Next, it checks the minimum version of Go. This checks to make sure that the version of Go you have installed in your system matches that of the minimum requirements needed to write a Buffalo application. Now we always recommend the latest and greatest version of Go, which at the time of recording is 1.12.3. So I recommend you always install that, although there are minimum requirements for 110 and 111 should you want to use those as well. Next thing we do is we check the Go path. Now in this case here, we're not inside of our Go path, and I know that because it gave me some information to check things. First, a couple suggestions. Make sure the capitalization works. Next, make sure that you're working under the source directory. Then it kind of gives us some information about where we are and what's happening. It tells us what our expected Go path is, which is /go. It tells us what our present working directory, which is also /go. And then it checks us for what build sources Go sees. And these are what the Go command uses when it's trying to compile your application. So our Go path is this last one here. So as you can tell, the problem we've got is actually this. We're not under our Go src directory, and that's what the problem is here. Now this goes away in a minute when we turn on Go modules. We'll talk about that shortly. But notice that we also get information on how to make sure our environment is properly set up. And it links to an article that you can read that'll walk you through each of the major operating systems and tell you exactly how to set up your Go environment. Next, it's going to check your package management. And we recommend that you use some sort of package management. Now here it's telling me that it's a warning. It's not required, but it's a warning. It tells us we're not using any sort of package management. And it recommends two different ones. It recommends Go module and dep. Now, Go modules are highly recommended as they are the future of Go, and they do make Buffalo and other Go development a lot easier. There are rules to it, and it links to this great documentation on the Go Buffalo site on how to use Go modules. The one thing you must understand is that Go module support for Buffalo products requires you to set the Go 111 module environment variable to on. It does not accept auto, or it does not accept, well, I guess it accepts off. It does not respect the auto setting, which is the default setting for Go. So we are outside of our Go path, which we know, and Clara is telling us that we do not have package management turned on. And if we went to the docs for Go modules when using Buffalo apps, we'd see that it does tell us to explicitly set that, and we're going to do that in just a minute. Next thing it does is it checks the path, and the path is your system-wide variable for binary executable lookup on your operating system. So when you're in a terminal on your operating system, the ability to call commands without first kind of prefacing it with the folder structure that that command is in, that's your path, and that's how the operating system finds those folders that contain your binaries. So it's very important that you add go path/bin to your go path. In this case here, that is true, so we are good to go. Now it's going to start checking a bunch of Buffalo related things. Now, first thing it's going to do is check node, npm, and yarn. Now, these aren't required for Buffalo development, but by default, the brand new, if you do Buffalo new and create a regular app without any flags, it does make use of the latest front-end development technologies, such as Webpack, Yarn, and Node. So we check to make sure those things are installed and that their versions are the correct versions for working with Buffalo, the minimum system versions. Now, if you don't plan on using those, you're building JSON APIs, or you just don't like those technologies, not a problem. You can easily move past this. It's not an issue. It only becomes an issue when you want to use those technologies. And the same goes here for databases. It's going to check the 4 most popular databases that you use with Buffalo, which are Postgres, MySQL, SQLite, and Cockroach. And it's going to check to see if the executables are installed, if it meets the minimum system version, and all that good stuff. And again, if you're not planning on using a database for your application, you don't need any of this. But if you are, it's useful to know exactly what's going on and where you stand in terms of your database of choice. And then finally, it's going to check the Buffalo installation. Now here, we don't have Buffalo installed in our system, and it's going to tell us exactly how to do that by going to the installation guide. Now let's talk about actually installing the Buffalo binary. Before I do that, I just want to clarify something. Buffalo is actually 2 different parts. First is the Buffalo binary or tool, and this is a collection of tools that make working with these applications significantly easier. Dev servers, testing, creating new Buffalo apps, etc. Then there's the Buffalo framework, and that is a completely different library. They're in the same GitHub repo, but one is a tool that is independent of the library. So it's often not uncommon to be working in an application where you're developing 0.12 and your binary is 0.14. So that is something to keep in mind, that it is possible to have those 2 out of sync. But we're not going to talk too much about that. I just really want to make sure that you understand that there are these 2 components. There's the tool, which is a binary, and then there is the package, the Buffalo package that you bring into your application, and that is the basis for what you build your applications on. So we're talking about installing the tool now, the Buffalo binary. There are a few different ways we can do that. One of the easiest ways is just go to github.com/gobuffalo/buffalo/releases and pull down one of the pre-built binaries for the version and operating system you want to use. Should you not want to do that, which is totally fine. There are several cross-platform ways, as well as ways for specific operating systems like Scoop on Windows or Homebrew on Mac. You can, of course, also install from source. Now, one thing I do want to point out here when we talk about installation is SQLite support. So why am I calling out SQLite support? Well, SQLite requires CGO, or C, and a C compiler under the covers. Now this has to be built on the different platforms that you're running on. So for example, if we built binaries on a Mac with C SQLite support built into it, it wouldn't work properly on Windows because they're different libraries. So if you want SQLite support, you're going to have to build from source. And that's okay. All you've got to do to add it, assuming you have a GCC compiler installed on your system, is to do a go get and build the source with the SQLite tag as we have here. So this will do a go get. -u is updating any libraries you might already have. -v is verbose, and that's not required, but I think it's useful to see exactly what's happening. And then here's the tags, -tags SQLite. And that's going to tell Go to call the build tag SQLite, and that's going to build your Buffalo binary with the SQLite CGO kind of bundled into it there. So now that you've installed Buffalo through the proper means for your system and requirements, you can check that it works by running Buffalo info. And this is going to run a specialized version of Clara. And what it's going to do, again, is run those same sort of checks that we saw with Clara, but it's also going to add more information at the bottom. And while we don't really care about that information right now, we will later. And running Buffalo info is incredibly useful and important when you go to open a bug. Run it, copy and paste the output, and add it to your GitHub issue, because it will make our job of helping you and others helping you with your issue that much easier. Plus, with the new Clara system in 0.14.3, we are able to give you helpful information right away that might solve your problem before you even get to opening an issue. So seeing that Buffalo info works and that we've got a bunch of green check marks, although my version of Yarn appears to be a little out of date, we look like we're good to go to start writing a Buffalo application. Now, before I go and start talking about generating a new Buffalo application, I just really want to touch back on modules, because modules do make working with things like Buffalo and other Go projects that much easier. So I highly recommend you're using the latest version of Go, which at this time of recording is 1.12.3, and that you've turned on module support. And to do that, you need to set your Go 111 module environment variable equal to on. Buffalo will only use modules if that variable is set to on. You need to explicitly opt in to module support for the time being. That will eventually change, but for right now, it's very important that if you do not turn that on, you will not get module support no matter where you are on your system, whether inside or outside the Go path. So here I have my module support on, so I'm ready to start building a Buffalo app. So let's start building our Buffalo app. To do that, we need the Buffalo new command. And the Buffalo new command is going to generate our brand new Buffalo project for us. But before I do that, I just want to quickly walk through some of the flags so you know what to expect and how to configure it to suit your needs as you go. So first, when we call Buffalo new, we have to give it a name. So Buffalo new my app, for example. We're going to use a trusty old Coke application here. That's kind of the hello world of Buffalo. Then you see we have a bunch of flags. The first flag is the API flag. And when we can build a brand new application using the API flag, when we do Buffalo new --API, what we're going to get is an application that has been stripped of all front-end components. So no templating, no JavaScript, no style sheets, and it's going to be set up for JSON API development. So if that's what you're looking for, add that flag and the app's going to be ready to go for you. If you don't add that flag, you're going to get a full-featured web application. You can configure your CI provider. You can set the DB type you want to use. So Cockroach, MySQL, Postgres, or SQLite 3 in this case, because I built my binary with SQLite support. If you don't see SQLite 3 in that list, you haven't built your binary with SQLite support, so if you need it, you have to make sure to do that. The default is Postgres, so if I generated a new Buffalo application, I'm going to get a Buffalo application that's set up to talk to Postgres. Docker, we generated a simple Docker file for you that we'll look at in a few minutes. That is a multi-stage Docker file. And what that means is it's got multiple build stages inside of one file. In the first stage, it's going to use the Buffalo base Docker image to compile and build your application. Then it's going to move it off to an Alpine image, which is much, much smaller and shorter and nicer to deploy with just your binary inside of it. So it's a really nice file, kind of already set up, ready to go. You can easily push it to something like a Heroku and have your application up in just minutes. Dry run shows you what's going to happen if you were to run this command without actually running anything. Force will delete the application if it already exists and write over it. Module, this is the name of the module you want as your root. By default, it's going to automatically figure out what that module should be. So when I'm inside my Go path, which I am right now, it's going to give me a Go path style module name. So github.com/markbates/coke. If I'm outside of my module, if I'm outside of my Go path and I've got modules turned on, what I'll get instead is just Coke as the name of the module, for example. If we don't want to use the database system that ships with Buffalo, which is a tool called pop, then we can just call the skip pop flag. And what that's going to do is just not generate any database parts to our application. Then you can bring your own along. So if you want to use Gorm or you want to use Mongo, that's fine. You're absolutely welcome to do that. Use skip pop and you won't get any database stuff in your code, but you will have to kind of plumb that all in later. And there is work happening currently to make it easier to plug in tools like Gorm or Mongo or whatever as part of the generators and as part of the tooling, but that's still a work in progress. If you do want front end, but you don't want to use Webpack, you just want to use plain old JavaScript and plain old CSS, that's fine. You can call skip Webpack and you're not going to get any of the Node, Yarn front end stuff at all. If you don't like Yarn and want to use NPM instead, you can call the skip Yarn. For VCS, by default, we set up a Git. We do Git init on your application when it's done. You can also use BZR if that's what you like to use, or none. And of course, if your VCS isn't listed here, please open a ticket and add support for it. We'd love to have it. And then finally, with DEP, adds the DEP package management system to our application. Now, again, I highly recommend using modules and not recommend DEP. And mostly because modules are built into Go, the tooling is a lot nicer and easier to work with as it's built straight into the Go tooling, and it is the way forward for most Go applications. So I don't recommend DEP anymore. I do, however, recommend that you do enable modules, again, by setting Go 111 module environment variable equal to on. So now before we go and actually generate our app, let's run it with the dry run flag and let's see what exactly happens here. So you can see it's going to generate a lot of files and it's going to put them all under a folder called /coke, right? So I'm in my go path /src/github.com/markbates. So when I do Buffalo new Coke, it's going to put it in a Coke folder underneath that. You can see it generates quite a lot of files here. It inits the module, again, to be github.com/markbates/Coke. That's because we're using modules. It's doing some go gets to make sure we have the proper version of Buffalo and whatever else we need. It's generating some Docker files, some models, installing some plugins, adding some more files, doing web stuff, setting up the front end web stuff, making sure that Yarn is properly set up, doing a git init, a git add, and finally a git commit all the way at the very bottom. Okay, so now we're ready to actually generate a Buffalo app. Now I'm going to generate a stock standard Buffalo application. What that means is it's going to use Webpack for our front end and Postgres for our database. And we're done. And here's the folder structure and file structure that got generated for us. Now before we go and jump into our application, let's make sure we're set up properly. First, I'm just going to open our application here in Vim, and I'm going to go to the database.yaml file, which is located at the root of our application. And this was what was generated for me. It generates 3 different entries: development, test, and production. And these are different environments our application may run in. So you can see here, it configured it with a few kind of simple defaults. The name of the databases is, in this case, the name of the app, Coke _ and then the environment, development, Coke _ test, Coke _ production, etc. There are a couple different ways we can configure this file. One that we see here with development, which is the broken out kind of syntax, where we can configure each individual component as a list in that setting. Or we can use it with a URL. Now this is super useful when you're deploying to production and you have a URL style configuration. Say with Heroku, for example, they put all theirs into an environment variable called database _ URL. So we can also accept a URL for configuring these types of database connections. I do want to point out this env or helper here. And what that does is that's going to look for either this database environment variable, database _ URL, or if that's not found, it's going to use this string instead. And the same thing for testing. Now, unless you're like me and have already set up your Postgres to make sure that the usernames and passwords listed here are correct, you'll probably have to either change your database.yaml file to reflect your system or add a user to your Postgres system, a super user to your Postgres system with these credentials. That's entirely up to you. I have one on my local system set up with these credentials, and it does make my life a lot easier because I could just kind of generate an app and start working. I don't have to keep tweaking the configuration. And then obviously in production, things are different, and we use an environment variable whenever I deploy an application to production. But assuming you have your database YAML configured with the correct username and password for your database installation, you then also have to make sure your database is running. Buffalo does not install, configure, or start any database for you. You need to do that yourself. So off camera, I have installed Postgres on my Mac. For the Mac, I enjoy the Postgres app website, and it's got a nice little binary. You download it, install it. It's super easy to run, has a menu helper and everything. But obviously different platforms are different, and you might not like that tool and want to install it yourself. The point really is that Buffalo doesn't install databases, it doesn't start them, nor does it configure users. You must do that yourself. So next, what I want to do is I want to make sure our application is set up, since we just created it. Now, there is a command called buffalo setup. And I highly recommend you use this command, both when you're generating a new application like this, as well as if you go and do a git checkout or something and pull it from your, say, repo, right? What it's going to do is it's going to make sure that it runs all the different checks, like creating your databases, migrating them, seeding, tests, plugins, NPM, all that sort of stuff. So I can just run buffalo setup, and let's see what happens. So now we've set up our databases, all three of them on our local machine, both development, test, and production. We've made sure to run our migrations. Of course, there aren't any currently. Seed the database if there is a seed task, which there isn't. And then finally run our tests just to make sure that everything is set up correctly. In this case here, we only have a few basic tests just to ensure the generated Buffalo app is correct, so they all pass. So now that we have our application generated and set up and the database is set up, let's actually start the application and see it in a web browser. So to do that, we use the buffalo dev command. When we run buffalo dev, it does a couple things for us. First, it builds our application. Remember, Go applications need to be compiled before they can be run. So Buffalo Dev will do that. It'll also watch all of your Go files and rebuild that binary and restart it for you when you change or modify any of your Go files. This means you don't have to do the cumbersome step of stopping your binary, running Go build, then starting your binary again. Buffalo Dev is going to do that for you. It's also going to watch your Webpack files, your JavaScript, your CSS, and other files, and it's going to rebuild those as you change them as well. So you don't have to start and stop the server for that either. As we can see, the server here is launched now on 127.0.0.1 port 3000. So if I open up my browser and I go to 127.3.000, we get our welcome page. So our application is successfully up and running. So knowing that our application is running, let's start taking a look at exactly how we got to that home page that listed the different endpoints we have in our application. Well, the real entry point to our application, like most Go applications, is main.go. And this is where Go applications and Buffalo applications start. Now, there's a lot of comments in here, and I'm not going to kind of cover them, but really your main function here is what controls your application. So what we're doing here is we're going to call into our actions package, get the app from there, our Buffalo application. We'll talk about that in a second. Then we're going to serve it, and if there's an error, we're going to fatal out. Now, this is a great place that if you need to do any sort of different things at the beginning of your app, this is your main function is the entry point to your application executable. So that would be the place to do it. So let's now look at this app method from the actions package and see what it looks like here. So if we were to dive into it, this is the actions app.go file, and this is where your kind of whole application is built. This is where you kind of set up your routing and that sort of stuff. So again, we've got a lot of comments in here, but I'm going to start here at the top and talk about these three environment variables and what they are and how they help you with your application. The first, this env, is the environment that you're running in. Now, by default, it is development. If you want to change that, you need to set the go_env environment variable to test, production, staging, whatever you may have. Once you have it as an environment variable, you can easily check it through the rest of your application should you need it. The next is this variable Buffalo app here, and this is a non-exported application and a non-exported variable, and that means that it's private. It can't be accessed outside the actions package. So the way you access it is by calling the app method, app function here, which returns a Buffalo application. And that's what we had in our main.go file. And inside of there, you can see there's a big if statement that checks to see if that variable is nil. And if it's nil, it's going to go and set up that variable for us. And finally, it will return it down at the bottom. So always making sure to return that Buffalo application. Back up to our environment variables, and we're going to dig deep into the app function in just a second here. I just want to cover this last environment variable, T, and this is the I18N translator. So out of the box, Buffalo supports internationalization, and it does that by the locales folder here. Under the locales folder, you'll find all.en-us.yaml, and this is where you can start putting your translations. And there's much more information available on the Buffalo site about translations. And if you look down near the bottom of your app.go file, you see there is a translation function which returns a piece of Buffalo middleware which sets up your translations for you. And of course, if you need more information, go to gobuffalo.io and look at the localization documentation there. So let's start by digging into our app function here, since this is what builds our application for us. So when the app starts up, which somebody asks for it the very first time, it's going to build all of this. And the first thing it does is it calls Buffalo new and passes in a few options. The two options that are probably most important are the environment option as well as the session name. So you can see we're passing in our environment variable here, so development, test, production, etc., and that helps Buffalo understand what your application mode is, so it can do different things in production versus development. Like, for example, as we'll see, in development we generate pretty strong error pages that tell you a lot of information, but we don't want to do that in production because it can leak details, so we don't. So we make sure we render a different page in production. But anyway, so moving on, there are other options that we can look at, and if we dig into the options for Buffalo just a little bit here, we can see name, which is the name of our application, and that's not necessarily that important. Address is how we can change different how we change which host we're running on, where what our port is, and that sort of stuff. That is the address. That is the 127. And this can be set using both the adder and port variables, or just using the adder setting here as well. Host is your pretty name for it. So in production, this would be like your www.foo.com. Whereas your address is usually an IP address or some sort of internal resolution for where this server is binding to when it starts up. Again, environment now is development or production, what have you. Log levels, we can assign different log levels to our logger. By default, Buffalo will generate a logger for you with kind of appropriate settings, the default being debug level. But you can add your own logger. Logger is an interface type from the Go Buffalo/logger package. So you can pull in one of those loggers, or you can write your own. It's a set of interfaces. The default is backed by Logrus, which is a structured logging system. Then you can set the method override handler. And for what we talked about method override, a lot of browsers only send get and post as HTTP methods. Now there are a lot more methods than that. There's put, options, head, delete, etc. So since the browser isn't that sending that information, but we want to respond to it, Buffalo supports that by having a method override. And by default, this will actually look for a parameter named _method and use that instead of whatever the actual method that was passed along the request is. This is very similar to what frameworks like Rails do, for example, to handle this situation. Now, if you want to have a completely different way of doing your own method or overriding, maybe it's not an _method variable, maybe it's some other piece of information from a session or whatever. I don't know how you want to do it, but you're certainly welcome to. It's fairly straightforward. It's a HTTP handler func to do it. Next is the session store. By default, we use Gorilla Sessions to back our sessions. When we're talking about, say, a web app, by default, it is a cookie store, but you can change that as well. When we generate a API application, what we get instead is a null store, because JSON applications typically don't want nulls, so that's what's kind of set up for you by default. But again, all of that can be changed. You could write your own Redis-based session store, use one of the other session stores that Gorilla offers, and much, much more. Workers are background workers that let you implement tasks in the background. So, for example, think a user uploads an avatar and you want to create all sorts of different thumbnail versions. That's what a worker would do. You'd pass it off to a background worker, background job system, and it would generate all those for you. By default, we use a very simple worker, which is just GoRoutine backed. But I definitely recommend you check out github.com/gobuffalo/worker for more information on the interface and how it works and how you can build your own custom workers for your own back-end systems like Factory or Kafka or whatever system you want to use to manage your background processes. When we call app_serve, which in turn calls app_start, it will start the workers. If you don't want your background workers to start, you just turn this off and it'll work. Or rather, it won't work. It will stop. It won't run any background workers for you. Pre-handlers, these are HTTP handlers, as in from the net HTTP library in Go, that are called between the server and the Buffalo application. So these are regular HTTP handlers that you might put in front of your application for whatever reason. Pre-wares are kind of like pre-handlers, but they take an HTTP handler and return an HTTP handler. So this acts as like a pseudo middleware between the server and the Buffalo application. So this is where you might pull in a third-party HTTP handler that does something like gzipping. You can add it as a pre-ware, and then Buffalo, it'll get called pre and post the Buffalo request as well. Prefix is not necessarily something you necessarily have to worry about, but what it does control is what your routes start with. So by default, this is really just an empty string, but as we nest things, we can change the prefix. This is also useful for multi-tenant applications as well. And then finally, there's a Go context down here, which we're not going to talk too much about, but understand that you can set your own context to your application should you want to. So back inside of the generation of our Buffalo app here, let's continue on a little bit. The next thing we have after we set up our Buffalo app is we have this app.use force SSL. App.use is how we register Buffalo middleware. And force SSL is just that. It's a function that returns a piece of Buffalo middleware to us. So if we can look, it's right here at the bottom of the file. And it returns a Buffalo middleware func to us, and it uses the secure library from Unrolled to force our web application to be SSL'd. So what happens is if this is enabled, which it is by default for production, but not for development or test, if this is enabled, this won't set up a SSL, it won't set up HTTPS and, with certificates and all that sort of stuff. What it'll do instead is if a request comes into HTTP, it will redirect that request to HTTPS. So if you're using something like Heroku, you could turn on automatic SSL cert management. You turn Force SSL on in production, and if anybody tries to go to http.myapp/myapp, it'll redirect to https/myapp. You just need to make sure that you have HTTP set up in your system. So if you're trying to run this and run it in production locally and you see weird errors or weird issues, it's probably because you have SSL enabled in Buffalo and it's doing the redirects, but you don't actually have SSL running on your server. Now before moving on, let's just look at what a piece of Buffalo middleware actually looks like. So there is a type called the middleware func, and it is a function that takes a Buffalo handler and returns a Buffalo handler. So here, for example, is a little example piece that shows you what that might look like. Do something is the middleware function because it takes a Buffalo handler and returns a Buffalo handler. And inside of it, it's going to return this function, which takes a Buffalo context and returns an error. We can do something before the handler. We can call the next handler in our chain passing the context, get back potential error, do something, and return the error if we'd like. If we look at a Buffalo handler, that is a very simple type as well. That is a function that takes a Buffalo context and returns an error. So our middleware func takes one of those and returns one of those. And this is how we can easily build middleware for our applications, like we do with the Force SSL. And we're going to look at how to build a small, simple piece of middleware ourselves in just a few minutes. Now the next thing that was generated for us is another piece of middleware, the parameter logger. And this comes to us from the param logger package. And what this does is it's going to log out query string and form parameters to your log to help with development and understand what's being passed and forth. But it'll also apply some filters and stop common things such as passwords and credit card numbers from being displayed in the log. And of course, you can configure this with your own filters to make sure that your system is nice and safe and secure. Next, there is a piece of CSRF middleware that is added to our application, and this prevents against cross-site request forgeries. You don't need that. So for example, an API app, when generated, doesn't have this piece of middleware, and that's because we're not too concerned about cross-site request forgery. However, in HTML apps, we are absolutely concerned about it often. And what that is, that's when somebody writes a form that posts back to our app, but it isn't hosted by our site, so a malicious form. So the CSRF will check the token in the form and on the site with one in the session and verify that the contents match, so that we can verify that the request payload that we got is in fact one that we had generated originally with one of its tokens. Now, if you don't need this, you can remove it. This is disabled in testing to make testing easier as well. Next, we have another piece of middleware, and this is the POP transaction middleware. So if you remember earlier, I talked about POP is the database package that we use by default in Buffalo applications. So if you generate your application with skip-pop, you won't get this piece of middleware injected. And nor do you need to have this piece of middleware in your application. It's entirely up to you. But what it does is it sets up a database transaction for each request. So when a request comes in, instead of talking directly to the database, this POP middleware will start a database transaction and add it to your context, so you can use that transaction throughout the rest of your stack. The transactions are either automatically rolled back or committed based off of whether you have an error or a successful response from your application. So when we come into our application, say to our home page, it comes into our Buffalo app. It works through the Force SSL middleware, which, because we're in development, is kind of ignored. It's going to log any parameters to that request out to our log. It's going to check CSRF. Now, because it's a GET request to the home page, it's not going to do anything useful. Then it's going to set up a database transaction for us to use in our actions and other pieces of middleware. And when we return back from our actions and middleware, the transaction middleware will check if there's an error. It's going to roll back the transaction. If there isn't an error, it's going to commit the transaction for us. If you want to do your own transaction handling, remove this middleware and do it yourself. You can't open transactions inside of other transactions. That's a big no-no. If you close a transaction, you've closed all the transactions. So keep that in mind. Transactions also do slow down your application ever so slightly because of the nature of what a transaction is. So again, it's up to you whether you want to use the transaction middleware. Personally, I really like it. I find it very, very useful and helps keep my apps nice and straightforward and simple. But there are certainly times where you may want to turn it off, and that's not a problem either. Next, we set up the translation system that we talked about before. That's our I18N translations. And then on these last two lines here, this line, the app.get line, is where we mount our handlers and where we actually set up the endpoints to our application. So what I'm saying here is on my application, when you see a get request come to just / so the root, we want you to, you're going to have Buffalo invoke the home handler. So that's what happens. When route comes into / that is a get route, it's going to call the home handler, which is going to process it. And we're going to look at our home handler in just a second. The last thing here to note is app.serve files. And what this is your public directory. And if we look, we can see we do have a public directory that has been generated for us. It has assets. When Webpack watches our assets, and we'll talk about assets in a few minutes, it's going to compile them and generate them and stick them here in our assets folder. And you can also notice that by default, all of our assets are fingerprinted as well, which makes it really nice for caching purposes. And we'll cover that in just a little bit as well. And we also generate a very simple robots.txt file. So in this very last line, and it has to be the last line, is it's kind of a fall through. What we're saying is anything that comes into /, which is, /foo also falls into that kind of bucket. If it hasn't been handled already, it's going to fall down into the serve files, and it's going to call the assets box. And if we look at the assets box, which is open, which is set up on and render actions render.go, it's this here. And what this is this is a Packer folder, and Packer is a tool that we can use to compile static assets into our binaries. So our JavaScript files, our CSS files, our HTML templates, whatever they may be, get compiled into our single Go binary. So we can ship the binary that Buffalo Builds generates without any other files attached to it, because all the files we need are inside that one binary. And so that's what Packer lets us do. So this assets box variable here is pointing at our public folder. And serve files here is able to work with that Packer box and serve files from our public directory. Okay, so now that we have an understanding of how our application is built, how middleware gets called, and how handlers get mounted and how public files get served, let's actually look at one of our handlers. By default here, we got this home handler that was generated for us. And if you remember, just a few minutes ago, we talked about the handler type is a function that takes a Buffalo context and returns an error. And then inside of here, when someone comes to / the root of our application as a get call, it's going to end up in here because that's what we had mounted in our actions app.go file. The request comes in, we get our context, and the Buffalo context has a lot of very, very helpful methods on it. The original response, request, session, cookies, parameters, functions you get a particular parameter. Because our context is also a context.context from the Go standard library, we support that interface. So there's a set field. There's the ability to log particular fields. on your context, as well as access to the underlying logger. Bind we're going to talk about later, but this is going to let us take forms and other payloads and automatically map them onto struct or another type that we give it. And we'll talk about that in a later video that's a bit more advanced. Render is how we render things out to our screen or to the console, to wherever it is we're rendering. And by doing that, we can use a renderer interface. We'll talk about that in just a minute as well. Error lets us easily return an HTTP error with a status code and other information in it. Redirect lets us, redirect to a different endpoint in our application. Data function is very useful if you need to get kind of a map of all the data inside of your context for whatever reason. For example, we use this when we generate an error page for your application. Flash lets us assign flash messages. And flash messages are messages that appear once to a user. These are great for kind of, you have successfully been logged in, or you have been logged out, or there was a problem, invalid username and password. Those kind of quick messaging back and forth to your user, and that's what flash messages are for. And finally, there's a file method which returns a binding.file or an error, and this is the way that Buffalo works with uploaded files. And again, we'll talk about that in a different video. So now that we understand what is available on the context, let's look at what we're doing here. On the context, we're calling the render function, and we're giving it a status code of 200, which is a successful status code. And then we're going to call r.html index HTML. And R is actually a render engine we have set up in actions render.go. So if we go back here, you can see we have our render engine set up, and we're going to give it some options. So inside of our render options, we've got a couple things we've got set up here. So first is HTML layout application.html. And what this is it's saying when an HTML app is loaded, request is made, we're going to wrap whatever you asked for to render as a template in this bigger template. So here we're rendering index.html, but it's going to be wrapped with a layout from application.html. And we're going to look at that in a second as well. We're going to use another Packer box to set the templates box, and this is the location on disk where all of our templates live. So if we look again at the file structure that was generated for us, we have a templates folder, and under that we have 3 files, application.html. And let's open that up real quick. And this is that layout I was just talking about. This is where we put, all the meta information and CSS and body tags for our application. And you can see we've got a couple things already set up in here. For example, style sheet tag. And this is going to generate a full style sheet HTML tag for you for application.css. But if you remember, when I was talking about the public folder, I showed you that all of our assets are fingerprinted. Well, the good news is the style sheet tag helper, as well as the JavaScript tag helper, will do the proper inserting of the correct fingerprint for your application. So you can just ask for application.js, and it's going to generate the correct script tag in this case with the correct fingerprinting already set up for you. Then we have a div here kind of set up for you, ready to go. There is a partial, and we'll talk about partials in just a second. And then there's this yield directive. And what the yield directive does inside of our template here is it's going to call our index.html template and push the contents of that into our application HTML template. Now, by default, we're using a templating system called Plush. But you don't have to use Plush. Plush is part of the Go Buffalo ecosystem of packages. It's an ERB, JSP, PHP-ish style of templating, and it's very powerful and very usable. But if you don't want to use it, that's okay. You can bring in your own templating systems. That is out of scope of this video right now, but we will talk about it in a later video at some point. So back at our actions render.go file, that's what our templates box is doing that. It's a box containing all of our templates. We're also going to add our assets box to our renderer. And then we can add any helpers we want. And helpers are kind of key value pairs where the key is something like foo, a string that's going to appear in our templates, and the value is going to be a function that we can call. It doesn't even have to be a function. It can actually just be another value. So for example, I can do something like year, and then I can do time.now.year, and I can add that to my helpers, and now that information is available to me if I were to print it off here inside my template. I can go back to my home page, refresh the page. There we go. And you can see way up here in the corner, 2019. It's not exactly the best place to put it, but you get the idea. We could also change that as well to instead be something more like this. It returns an int. So we're going to return time.now.year, not yar, but year. This is a different way of doing it in that now it's because it's a function, it's going to be more dynamic, right? So if a year changes, it's going to constantly change. It's going to change, whereas before we were kind of hard coding a value into our system here. But we also now have to call it as a function in our application. So again, if I refresh, it works. And I'm just going to change this maybe to month. Let's see what happens when I do that. Month apparently is not an integer, but do notice that it actually Buffalo shows you exactly what the error was. On line 25, cannot use time.now.now as month, type.month as type int and return argument. So instead, let's change it to something like Unix nano instead. How's that? And that might actually be an int64. So let's change our type to an int64. And that should resolve our error. If we go back and refresh, there we go. Now you can see we've got a giant number up there. So adding helper methods and functions is pretty straightforward. We do it right here in our render.go file. Now we're not going to talk deep into exactly how helper methods work and all the different things you can do it. That's out of the scope of this video. And there's certainly resources on gobuffalo.io already that talk a lot more about this. And I recommend you check those out. So before we head back to our home handler, let's talk about rendering real quick. By default, our context has a render method, and it takes two things. It takes a status, as we saw, as well as a renderer. So what is a renderer? Well, it's an interface in the gobuffalo/buffalo/render package. And it looks like this. It has two functions, the first being content type that returns back a string. Text/HTML, application/JSON, whatever your content type happens to be. And it also needs a render method. And the render method takes an IO writer to write to and data. And data is a map of strings to empty interfaces, so anything, and returns an error. And with that, we can do pretty much anything we want, and you can write your own custom renderers as well. By default, the render package has a bunch of these and ships with what was called the render engine. And the render engine takes some options that we had seen already. These are things like HTML and JavaScript layout, templates box, assets box, helpers, template engines, and default content. Now, we're not going to get into all of that. But what I am instead going to do is look at very quickly some of the different renderers that are available on the engine type. So you can see there is an auto renderer, and what auto rendering does is it takes a Buffalo context, or actually it takes a context, as well as an interface, and that's usually your model, say the user or whatever the widget is that you're trying to do, and it's going to figure out how to render that particular thing based off of the incoming content type. So if it's HTML, it's going to try to look for, let's say it's a widget struct, it's going to look for the folder called widgets under templates, and then figure out, is it index, show, edit, new, whatever, based off of the route that came in. If it's a JavaScript, a JSON request, it's going to attempt to render that struct as JSON, whatever the type you give it. Download is for, writing file downloads. It takes the context, the name of the file, and then a reader to read from. Func lets you kind of do a one-off renderer by giving it a function. HTML, JSON, JavaScript, plain, string, template, and XML are a whole bunch of other renderers that you can use. The ones that you're going to use the most are probably auto, HTML, JSON, and maybe JavaScript, depending on how crazy you want to get with it. But knowing that those are available, we can easily call any of those functions in our application to render our HTML or JavaScript or what have you. So back in our application here, we're going to call the render engine that we've set up in actionsrender.go. We're going to call the HTML function. We're going to give it our index.html file, which is going to get looked up by the render engine in our templates folder, and it's going to find index.html. It's going to figure that out. It's going to inject that into application.html because that is our layout. And then finally, it's going to return all of that back to the user with a 200 status code. And if we were to open up the generated index.html file, there's a lot going on here, but you can absolutely just delete the whole thing, say hello, refresh your website. There we go. And now it says hello. So we have kind of completed the cycle of getting our application up and running, installed, and walked through the whole process of how we get to the hello index.html endpoint. And that's where I'm going to end this video for today, because that's a lot to take in already. And we're going to build a few more videos where I'm going to keep looking into a basic Buffalo application like we're doing here, and take it from this point and kind of move further. And we're going to explore some of the other subfolders here, as well as actually do a bit more coding and see how all these pieces change and interact as we start doing a little bit of coding. But anyway, that's it for now, and I hope this helps. This video was brought to you by Gopher Guides. If you are an organization, conference, or user group looking for Go training, please visit gopherguides.com. For more great videos like this one, please visit gopherguides.tv.